Good afternoon, everybody. I'm Phil Brown with jitcadcam, and today I'm kicking off another new series called Turning Tuesdays, where we will be going through different lathe parts from start to finish. This week's video is dedicated to the basics, where I will cover how to create a setup for turning all the way through to posted G-code. So let's go ahead and jump into it. As you can see, I already have my part loaded into Fusion 360. So with that, I'm going to switch from the design workspace over to the manufacture workspace. This is going to allow me to set up my actual operation type. Am I doing milling? No, in this case, we're doing turning today, and I still need to create my setup. So from my setup, in the event you didn't pick the correct operation type, we can go ahead and change that here. I am skipping over machine just for this purpose. We're doing a very simple part. There is going to be no need for a machine. I actually am going to be making some better content on why you would use a machine. But moving down here below is kind of like we've talked about in my milling video, if you haven't watched it. All we're doing is telling the software, I want to pick how I orientate my part. I did not luck out on this part where my Z-axis, as you can see in the world, is orientated the right way. Now, Fusion is automatically looking for a round surface to determine Z to spin around. However, in this case, my Z-axis is pointed the wrong direction. So what I'm going to do is I'm actually going to click the tip of that Z, and you're going to notice that it flips it down to the other end. In the event that you just want to use the checkbox here, it's still more than okay. Now, I do know that on a lathe, we work with Z and X, so I'm going to rotate my part manually, knowing all my tools are coming in on X, and then I have the Y-axis in the event that your lathe actually has a Y-axis. So moving a little further down here, what we have is a safe Z. And to see what that safe Z means is this is kind of the rapid point where our tools are going to go to before it starts to work inside of our part. Very, very handy if you're trying to save cycle time. Again, for many of you users, there's no reason to adjust this with what you're doing. So going down a little further, we're working with that one body inside of our file. We want a spun profile. Granted, we don't have any cross holes or anything to worry about on this part. And then our chuck reference, you could set this to what you like. I'm going to leave mine just referenced 400 behind. And the plan is to come in and part this off in one operation. Jumping over to our stock, you're going to notice that we have a fixed size cylinder. To create a much more dramatic look to this part, I'm going to increase the diameter of my stock. I'm also going to increase the length of my stock. And then from that, I'm actually going to offset my part from the front of my stock. So this is kind of a key element here so that we give it just enough room to create a facing cycle on the front, giving us that nice clean machine surface. One trick here for some of you is I am referencing the front of my stock. You may actually want to reference the model front. So if you're somebody that likes to go in, face your part, then set your actual work offset to your model, I prefer to set mine off the stock front. Again, there's no right or wrong way here. However, if you have an operator looking for the coordinates all coming from the model front, that's where you could switch that. So jumping over to our post processor tab, again, we can change our program number, our work offset numbers. Most of you are always going to use work offset 1. I would suggest if you have 0 set up in your machine, you change it from 0 to 1 inside of Fusion, and then just right click save as a user default. But that kind of wraps up creating our setup here. We can now jump in and start to add our toolpaths. So I've already given it away, and Fusion does a really good job of walking you through this, where the very first turning operation in your toolbar is turning face. Also, if you drop down that menu, again, this is kind of streamlined as to what we want to do. We're going to face, we're going to rough, and we're going to finish. So let's go ahead and do our turning face. Again, like always, I always tell people, if you're a little confused or this is your first time on some of these toolpaths, go ahead and hit OK. What OK is going to do is automatically bring up the Fusion 360 tool library because we never told it what tool we want to use. And I'm going to use just some of the default tools inside my library. Now, your library may actually be turned off if this is the very first thing you've done in the CAM side. And all you need to do is you need to click this Turn All Libraries On, and then you will see that it's giving me strictly turning tools based on our operation to start with. I'm going to go with the turning general. I'm going to go ahead and slide this menu over so I can grab just a simple CNMT right-handed tool. An 80 degree is really all I'm looking for, and I'm going to hit select. So as you can see, with my Z, X, and Y, my tool is coming in on X already. I'm getting a couple different colors when it comes to my part. So that dark blue or purplish color is actually my part. The yellow is my stock boundary. This green kind of shaded area is my physical stock as a cylinder. And then I have my toolpath lines. So again, this is where Fusion really speeds up the process, and we can go in and investigate what's going on with this toolpath. So I did review this in my milling video, and I'm going to review it here. It's just a little different thought process, right? So our geometry, a good way to think about geometry is in the Z and X coordinates right now. So where are we constraining that toolpath in Z and X? Well, we want to machine all the way to the model front. Now, my radii is going to be that X-axis diameter working into my part. So this is backwards because normally you have a heights tab, which is your Z. In this case, our Z is more built off of geometry. Now, our radii is more of our X-axis and containment. And if we actually look at this a little bit more isometric for a moment, you'll see how it gives us cylinders for inside and outside. Moving a little further on here, as soon as I get orientated back, we have our passes tab. Again, the blue line is the key element here. So the blue line's a little tricky to see here, but whenever we want to modify that blue line, which is the actual tool path, not the green, yellows, and reds, which are our rack bids and our linking, but just the blue line, we always go to our passes tab. So one thing I may actually want to do based on this part is I have my actual ability to say I want to make multiple passes. And if you do remember, I did leave 40 stock on the front. So if I go to a 20 step over, automatically now I have 2 blue lines in here. I didn't change the length of my blue line. I really didn't change the start and finish of my blue line. I'm just modifying how many blue lines I have. So lastly, your linking tab. Again, for most of you, you're really not going to mess with much in the linking tab. We will once we start to get into turn mill and things like that, just because we need to worry about a sub spindle and where we're chucking. But that's basically it when it comes to the facing tool path. A lot of times we're just selecting a tool, maybe giving it multiple step overs, and that's it. So I'm going to go ahead and hit OK. And now if you're like me and maybe you don't like to look at the stock here, we could always turn our stock off. And you have so down here at the bottom, if you click the little pyramid shape, and you could also hit F8 on your keyboard if you're using a Windows machine. I don't know what the command is on a Mac for most of you, but as you can see, I got rid of that actual profile. So we faced off our part. Now let's go ahead and do some OD turning. So again, I'm going to go into my profile rough. And as you're going to see, and this is the part that I absolutely love with Fusion, let's not change anything. Let's go in and hit OK. And what we're going to notice is automatically it has gone in and referenced the profile of our model and started to create our tool path. So as I've mentioned before, is we want to now maybe adjust the containment of our tool path because we are starting from model front, which is perfect, faced off our part, right? Now we're stopping at the exact model back. So let's go into that tool path. And now thinking about it is I want to adjust my Z-axis containment. So we're going to go to geometry. And in this case, it's set currently to model back. We are going to come in with a part off tool. So we may want to actually do an extension past the back of the part. So let's go ahead and add in a tangential extension. And I'm going to just give it 200. And let's hit OK. So what you're going to notice happen now is we are going 200 past the back of our part, but we are doing what I like to call waterfalling or undercutting. And this is, again, one of those things that we can determine what's happening and how we can adjust that. So in this case, we want to modify not where the blue lines are in a containment of X and Z. We want to modify how the blue lines are acting. So again, we go back into that turning tool path. We go down to our passes tab. And what we have happening is a grooving cycle. So we can go ahead and say, don't allow grooving. And we can hit OK. And now, as you notice, we're coming in nice and square all the way down to the back of our part and cleaning everything and anything up. So again, with very simple changes, we've made a lot of different things happen inside of Fusion 360. So from here, let's go ahead and set our actual OD finish cycle. So this way, we're going to go in and we're going to say turning profile finish. And again, I like to just hit OK and allow that toolpath to do the bare minimum. As you can see, again, we have a little bit of water falling here, and we're also not going back the past the back of the part. So we can go in and we can edit that. Again, we're going to say 0.2 past the back. And then in our passes tab, we're not going to allow grooving, and we're going to hit OK. And now, as you notice, we're coming up, around, and all the way to the back of the part. Now, I am getting a warning, and this warning is very common for a lot of users. The lead out has been modified due to a gouge with the remaining stock. What does that mean? Well, we're getting all the way back here to the edge of the part, and then we're kind of rapiding out with that yellow linking move. So we could fix that. And how we could fix that is we can actually go to our linking tab. Again, as if you look, you have green and yellow lines here. That is part of the green and yellow on my part. And if I go down to the bottom, there's what's called allow lead to cut stock. So we're going to go ahead and turn that on, and then we're going to go ahead and hit OK. And what you're noticing now is we're coming all the way down and around, and then we're leading out into that material and retracting out after the fact. However, if I turn on my second toolpath by holding Control, we're going just a hair too far past, or we're causing a collision into that material, which is something we might not want to do. So again, we can go back and edit. And in this case, we're going to go ahead and we're going to look at doing a radial extension. So radial extension is actually going to, instead of stopping right there, it's going to continue that path all the way down out of my part. Then it's going to wrap it away. Again, preventing that whole idea of causing a collision into my material or burying that tool and causing any type of breakage of tool or problems inside the part. So let's go back in there one more time. Again, the cool thing is we can now turn off allow lead to cut stock. And again, no changes to this part at the end of the day because our lead is up at the top. It's not actually in our stock in any way, shape, or form. So we're all clear here. If we had a smaller piece of material, maybe a lead to cut stock would be the way to go. But in this case, we're basically set and ready to rock. So now we have actually created our outside turning profile. We've done our face, our OD rough, and our OD finish. I'm going to go ahead and simulate this. And then I'm going to go ahead and hit play. And everything's looking good here. We're coming through. We're making all of our cuts for the inside and the outside of our part. Everything is shaping up very well. So now if your simulation doesn't look like me, I do recommend that you switch to a comparison. This will give you a color coding to be able to see what's still got material and what doesn't. Same thing as well as you could actually change your tool path. So as you guys notice, mine is just a little bit of a tail. I changed it from all tool paths to tail, making my life much easier when looking at this actual simulation. So let's pivot now. Let's actually do some inside diameter work. However, before I do my inside diameter work, because I can't really see from this side view of my part, actually this would be a top-down view if we're thinking in the machine, I'm going to go up to inspect and I'm going to do a section analysis. And as you can see, the origin of my part is set to center of my part. So this is a key element, but I can grab that plane and actually split my part in half. The problem is right here is that we have the wrong half of the part, which is not a big deal. We just click flip, and then we can go ahead and hit OK, giving us that section view. And if you wanted to, you could go back and hold Control like I'm doing and picking my tool paths, and you see all my paths on the outside of the part. One neat thing is with the continuous rest machining, as you're seeing, if I just click my last profile, which is that finish path, it's showing me my yellow stock manipulated as I go. So now let's do our inside work before we get to our part off. So with the basis of this, we need to start with either a center drill or a spot drill and then go into our drilling procedure. So I'm going to go up to drill, and I'm going to now pick a tool because I'm starting to get familiar with Fusion's user interface. And for the sake of this part, I'm actually going to just use a 3/8 90-degree spot drill. I'm going to go with my aluminum drilling speeds and feeds. And from there, I need to set my profiles for drilling. So if we go to the geometry tab, we need to pick a face to drill. So what this is allowing us to do is to pick what is it that we want to drill. We want to drill the inside of our bore on center. I pick the inside of my bore. Now, what I don't want to do is I don't want this actual tool to start inside of my part below that actual chamfer. And I don't want to drill all the way to the bottom. So in my heights tab, I like to work from the bottom up. It tends to make more sense. So I'm going to actually say I want to go from the whole top, or not the whole top, I apologize, the model top. And then I would like my top height to also be model top. So what's going to happen here is we're going to start at the very top of our model, which is this blue line. And then we want to drill to a model top minus 0.150, for example. So as you can see, the tip of my spot drill is getting down inside of my part, allowing me to actually open that up, because next thing I'm going to do is I'm actually going to drill out this 1/4 inch hole or whatever size it is before I come in with my second drill and then my boring cycle. So from that, we could go ahead and hit OK. And then we can now step up into our drill. So before I do my drill, I'm going to again do my inspect. And that diameter of that drill is a 1/4 inch like I thought it was. So let's go ahead and do a drill. Let's go in and select our drill. We're going to come down here into the Fusion library, and I like to just arrange my stuff by diameter. So I can quickly scroll down and find my 250 drill. In that case, those are tapped. So let's switch it over to drill only. And we could scroll back up. So here's our 1/4 inch drill. Again, this is aluminum, so we're using the aluminum speed and feed. Our geometry this time is going to be that smaller cylinder face, but again, we don't want to wrap it all the way down in our part and start there. So we change our heights, and we're going to say we're going to start from model top. And then what I'm going to do is I'm actually going to drill all the way to model bottom, and then I'm going to break through the bottom. So we're going all the way down past that backside chamfer. And then I'm actually going to give this a breakthrough amount, just so when we go ahead and flip this over, or if we part this off, we don't have to worry about anything getting in the way based on that actual drilling cycle. So this is a pretty deep drilling cycle, so I may want to go in and actually change my cycle to a chip breaking. The nice thing with chip breaking is it's actually going to do pecking intervals, and then it's going to do a full retract after so many intervals. So as you can see here, is I have a pecking depth, and then at a certain depth, we're actually going to go ahead and do a full retract. So this is automatically calculated based on my tool and my speeds and feeds, and I could change this, but I'm going to leave this mainly default on what we're doing. Another option you could do is a deep drilling with a full retract. I don't recommend that unless your machine cannot do a chip breaking, or if this hole was much deeper, I would actually go for a full retract. It's just going to add time to your cycle. So let's go ahead and hit OK. And now we have our actual drilling cycle, and we've pre-drilled everything out all the way in. Hey all, before I jump into the next couple of parts of this actual video, I want to go ahead and stop and ask you all to like, comment, and subscribe to my channel if you guys thoroughly enjoy the content that you're getting so far. As well, I just wanted to remind you all that here at jitcadcam, we are here to help you in any way, shape, or form. So there's actually a link for support down below where you feel free to put in tickets so that at any time we can help you with what you're doing and getting you guys on your way faster and more efficient. That said, let's get back to the content and see what else we can do with this part. All right, so we finished up our 1/4 inch hole. Let's go ahead and go back in here and drill out the next size up that we want to use. So I'm going to go to my drilling profile. I'm going to go out and I'm going to select my tool. And in this case, I'm just going to use a 3/4 inch drill, allowing me to get inside of that part. Next is my geometry tab. I pick the cylinder face. And from here, I have the ability to actually say auto merge hole segment, again, bringing that all the way to the top of my model, so I don't have to worry about a random plunge as we go into this part. Again, based on this drill, I'm just going to do a standard drilling. I'm not going to do any type of crazy cycle or anything of that nature, and we could go ahead and hit OK. From here, we now can chase that actual bore with a boring bar. So Fusion doesn't have a bar or a bore toolpath, so to say, but we do have turning profile rough. And one thing that turning profile rough does have is an inside versus outside profile. So let's go out and select our boring bar. I'm going to go back to my Fusion 360 library. I'm going to go ahead and say turning bore, and I'm just going to grab the default boring bar and hit select. One thing I love about Fusion is I'm going to first off start by hitting OK, and we're going to see what we get from a toolpath standpoint. So at this point, we are going way too deep. And we're also wasting a lot of time boring out something that's technically not there, right? So let's go back and make those adjustments. The first adjustment I'm going to make is based on my geometry. So what I don't want to do is go all the way to my model back. I want to go to a selected face, and that's going to be the bottom of my bore. And I'm going to go ahead and hit OK. And just like that, we've contained, again, in just the Z-axis, how far that blue actual toolpath lines go inside of our part. So now if we go back again, one neat thing I could do is we could go to geometry. We could go ahead and turn on rest machining. So what rest machining is now going to do is only chase that yellow shape that you see after our profile of drilling. So I'm going to go ahead and turn my stock back on here. And you're actually not going to see that in that view of stock. So we're going to go ahead and leave that off. And we can look at where the yellow has been removed. So again, as if I use control and I hold these two toolpaths, you have the purple where I drilled, and then you have the blue where I came in and I bored out the inside of that profile. So if we go ahead and simulate this, let's give this a glance and see what's going on. I'm going to let this go really, really quick here. Again, we are getting a collision. So if we actually look over here on the right, I have stop on collision. The back side of my tool is making a collision with my part. So I'm actually going to click on my screen and drag across and see at what point are we making those collisions and why. And it's all based off the fact that I don't have the relief on the back side of that tool to make this actual cut happen, right? So we can either adjust our tool or we can do some adjusting with our toolpath. Let's adjust our toolpath a little bit before we get into swapping out boring bars. Again, I'm using a default tool for this in the library. So realistically speaking, I would have already had a different boring bar set up, but let's go make some adjustments. So my inner radius is kind of my start point, right? And then I have my clearance, which my clearance is always going back to my stock inside diameter. Well, in the case of this part, we've already pre-drilled it with a 1/4 inch tool. So I could actually go in and I'm going to do a selection, or I could tell it a diameter. In this case, I'm going to say 0.25 for that drilled hole. And then I want my clearance to reference my inner. And the reason why I want it to reference my inner radius is because I don't want it retracting back to the stock center line every time. So I'm going to say inner radius, and I'm going to say like minus 0.02, just enough to get away from the center line of that part and get out of where we're going, right? So again, we go ahead and hit OK. Again, there's our now new tool path. You're noticing that I'm coming in much further out, and I'm starting that profile way down in the bottom and working my way out. Again, this could cause a dilemma based on what you're doing. And if we simulate this, we'll see that in real time. Again, we're going to speed through this. And then boom, there's the backside of my tool hitting. So again, not the best of scenarios for this specific tool. And if you've ever worked in a job shop like I have, we all know that buying new tooling isn't going to happen. So either we go to a smaller diameter tool and come in here and bore this out with the proper relief, or maybe we change our strategy, right? And I'm going to change my strategy by going to my passes, and I'm actually going to say, let's do vertical passes. And what we're going to do is we're going to go ahead and hit OK based on that. And now what you're going to see is we come in and we're starting to do vertical passes, but we're starting all the way into the depth of the pocket and working our way outwards. Again, going to cause that collision on the backside, or we should simulate this to see what will actually happen. So let's go ahead and hit our simulation button. And I'm going to click my mouse and I'm going to drag. And as you're seeing, we're actually starting very, very far out. We are getting a little too close for comfort in some cases. And I could adjust my step over, but it does look like with the relief of this tool, we could get away until we get all the way down here at the bottom. So a little better approach to this is going to be based off the fact that we should go in and we should go back to our horizontal passes. And we should edit our tool. So I'm actually going to edit this tool based on right-clicking the toolpath and going up and going to our cutting data, not cutting data, I apologize, our holder. And I'm going to change our cutting width to 625, but I'm going to divide it by 2. And what you're going to see is this is the radius from center line of the tool to the tip of the tool, right? So 0.3125 or 625 divided by 2. I'm still keeping the same insert size and everything of that nature. But now we have a dramatically smaller tool going down inside that pocket. So we're going to go ahead and regenerate this tool path. And then from there, we're going to, again, let's just go ahead and simulate just that tool path. And now we can hit our play button and see what happens. So again, we're still getting collisions on the backside because we never drilled that hole far enough down to give us the relief that we needed. So let's go back and actually drill that hole much deeper. So this is one of my favorite things about having a CAD-CAM software, allowing me to see visually what's going on before I ever get to the machine. But let's adjust our heights. Let's take this guy down to, say, minus 100. And if we zoom in here, we can see we're actually getting down inside that chamfer now. However, we're not so far deep, we're hitting the part. We're gonna hit OK. And then because of our rest machining, we do have to regenerate this tool path. I used Control G, and that actually cleaned up that path even more. Again, we can go into our simulate and see what happens with that tool path now. So based on making a lot of different changes inside of our profile, again, we are still crashing the backside of that tool because of the angle of the drill. We are seeing this in a real-time, real scenario situation. Again, this is very, very handy depending on what you guys are doing or how you're trying to fix these problems. What I'm going to do is I would actually switch out my drill bit, or I would go with a drill bit that actually has more of a flat bottom to it. And I'm going to do that right now in real time, where we're going to go back to our heights tab at 0. And then I'm going to right click, edit my tool. And the tip of that tool is actually not going to be 118 degrees. It's going to be 180 degrees, making it a flat bottom drill. And as you can see, we're now flat bottom drilling all the way in. One thing I wouldn't want to do, though, is go directly to hole bottom. We're going to stay away from hole bottom by about 10. And then we're going to regenerate our actual tool path to go in and clean everything up. So once again, let's simulate this and see what we get. Go ahead and hit our play button. Again, we do have a little bit of a collision there. And again, that's because we keep coming back to that center, but we're cleaning up so little stock in here. Our stock to leave tends to be a little bit more of the problem than anything. So again, as we can adjust these tool paths more and more, if our stock to leave was like 12, actually we want 12 in X, and we'll keep it at the standard 4 in X, 12 in Z. Now you can see we're no longer touching that bottom. And again, I left 10 with the drill, and now we've cleared our part and everything is set to go. So let's go ahead and pivot over real quick to our parting. So we're going to go up to the top. We're going to say turning part. We're going to select our tool. We're going to go ahead and go down to our Fusion 360 library. We're going to go to turning groove. We're going to grab the OD turning tool. So the nice thing with Fusion is it's automatically recognizing where it needs to go and what it needs to do and part off our part. But as you can see, we do have an edge break on the back of our part that we need to adjust to. So there was a 50 thou chamfer on my part. So if we go to geometry and we say edge break, I want a chamfer of 50. So we're going to go ahead and say 0.05. I'm going to hit enter. And one thing that is going to happen is it is going to be quite dramatically weird because it's so far out on my part. And when I simulate my part here, we're going to see that when it comes in to do this, that it doesn't even actually touch our part. So again, as I'm clicking and dragging across my screen, so there was the peck into our actual chamfer. We're not even close to putting that chamfer on our part. And the reason for that is because of our X diameters based on our part. So if we go back to our radii, and we actually say our outer radius is going to be our model OD, that is going to allow us to now bring that chamfer way down. And if you see, that blue line has been adjusted. My actual retract, now this is a personal preference. Again, my retract height might want to be my stock OD, which now really dramatically shortens those blue lines. So I'm dropping my cycle time. I would just be cautious because we're now starting to wrap it down to the exact OD of my part or my raw material, and that may cause a crash. But again, we go in and we simulate this, and we're going to go ahead and just swipe this through. Make it a little easy on us. So we come in and we do that little peck portion. Let's go ahead and restart that operation. We'll hit play this time. It'll be a little easier on all of us. So there's our actual tool path coming in. There we go. Speed it up just a hair. We did that first little peck, and then we came in and we chased that actual chamfer profile, putting that backside chamfer on our part when we parted it off. So now that we have a program that we're happy with, we're going to go out and run this in a couple of stages. I'm going to grab all of tool 1, and I'm going to right click and I'm going to hit post process. I'm going to go out to my library and select my post. In this case, I'm just putting it on a Haas ST15. I can actually control things in my post based on these toggle boxes to the right. They will save once you change them based on your machine. But let's hit post and see what we get for a G code. So as you can see, we are calling out our safe starts, our spindle speed clamps, our home position rapids, even our tool callouts, and then our spindle speed going into our cycle. Again, this is allowing me to offline program my parts, detect in the simulation whether or not I have collisions and problems, and get good known G code out of the machine. So that concludes our very first Turning Tuesday video on how to do a simple bushing with some boring tips and tricks for each and every one of you out there. And as I said before, if you guys are thoroughly enjoying this content or you want to see more content, by all means, like, comment, subscribe, send me parts. I would love to get parts from each and every one of you, allowing me to actually create video content to help all of you out in the community and get everybody up to speed with Fusion 360 and get it into your shops and using it the correct way. With that all said, as always, you guys have a great rest of your day. Look forward to another video tomorrow.